Hi, Gary.
Good morning.
Good morning. So I got it live streamed.
You've been in touch with Mark?
Well, yes, I mean yeah, I confirmed it with him.
I like the title of the talk.
Yeah, it's very good. Maybe I should send him a quick reminder.
Is there any update on our speakers later on? Fill out the schedule, sort of.
We're okay until 22nd April, I believe. Let me see. Well,
I guess what I was thinking of is that the May we have the education, training, and certification, and we don't have names by them.
mhm.
I assume John Beverly will be one of them, or at least organize it.
I sent him a quick reminder.
Has Nicola given you a title for his talk?
He gave me a tentative title.
Okay, okay. I don't see that on
Uh,
the. It might
didn't I
be
post
more
that?
attractive if we had a title.
Oh, I should. Yeah, I should put that in. I was waiting for him to give a confirmation that that's the title he wants. Mark, you're here.
Yes, you said I was waiting until August.
There we go.
Good to see
So,
everybody. Hi, Ken.
so glad to see you.
Yeah, it's been a while.
So we're about to begin. I'll start it in a moment. Well, I guess Okay, so I guess we should start. Welcome everyone to the Ontology Summit 2026. Well, today is the 8th of April 2026, and we are really excited at the prospect of hearing Mark Musin. Mark is a professor of medical informatics at Stanford University. He has an MD from Brown University and a PhD from Stanford. He conducts research related to intelligent systems, semantic web, reusable ontologies, and knowledge representations, and especially in the biomedical area. He's really especially well known within our community for his system known as Protege, which has been used by thousands of developers and probably all of the ones who are here today to build our systems. And he's begun to explore the use of knowledge-based technology to monitor a variety of data sources in an effort to detect incipient pandemics, including those caused by possible acts of bioterrorism. So with that, I will hand it over to Mark for his really interesting title of talk, Reports of the Death of Ontologies Are Greatly Exaggerated.
Thanks so much, Ken. Let me just get my slides up here. And hopefully you can all see those okay.
Yes, looks very good.
What I want to do today is, well, in the theme of the summit, really take a look back, given that our goal is to sort of understand where we've come from and to see where we're going. And I thought it would be useful to make some points that actually I've made in a couple of other venues, but it would be worthwhile discussing with this community on where we stand with the ontology community more broadly. Most of us started our work at a time when people were almost embarrassed to use the word ontology in professional discourse. And now, of course, it's just part of the vernacular. And it's really exciting to see where we've gone. But also, I have a caveat for where I think we're going, and I want to discuss that with you. Also, I want to make it clear that I'd like this to be a dialogue. There aren't that many of us on this call. So feel free to interrupt. Feel free to raise questions. I'm not going to be able to easily monitor the chat while we're talking this morning, but just butt in with questions, and certainly I'll leave a lot of time at the end for us to talk as well. So many of you know that one of the major activities in my lab over the past few years has been trying to make sense out of all of the biomedical ontologies that exist in the world and to try to put them all in one place so that people can get access to them. We have a system called BioPortal, which basically has now over 1,000 ontologies that are publicly available. Basically, all the known publicly available biomedical ontologies that people can access. And we're very excited that this gives enormous numbers of users the opportunity to get access to biomedical ontologies and to use them in a variety of ways. And that's also very, very comforting and reassuring for our line of work. I have to tell you, I was put aback a bit, though. We recently submitted a proposal for renewed funding for the BioPortal resource. One of the reviewers basically trashed the proposal, saying, "This is a terrible idea. All these ontologies are awful. You shouldn't be collecting ontologies. You should be building new ones. You should be using LLMs to go out and find primary sources and replace all these bad ontologies with good ones that you construct with AI." Well, I obviously have a lot of thoughts about that. I have not responded yet to the funding agency as to my feelings about that review and whether it should be taken seriously. But it's a warning sign for what's out there. And actually, these warnings have been coming for some time. Let me tell you a story, and it's a kind of a sad story. When we started BioPortal 25 years ago. This was a project that began under an initiative at the National Institutes of Health called National Centers for Biomedical Computing. And we created BioPortal, and we thought this was, really the greatest thing around. This is BioPortal as it existed about 15 years ago. There have been other repositories for ontologies that have come along since, as you know, but BioPortal was probably the first one for publicly available ontologies. And we were excited by what we had accomplished. We had our final meeting of the SAB, our Scientific Advisory Board, and we were able to show them this, what we thought at the time was a beautiful user interface. Obviously, our UI has changed. And then we showed them some data. We showed them that the number of page views for BioPortal seemed to be increasing exponentially. We showed them that we had large numbers of users and our user base seemed to be steadily increasing. We thought this was wonderful news. But even more exciting to us, we showed them the API calls that our system was getting. And we showed them over time that more and more people were accessing biomedical ontologies programmatically. This looked like a trend. And we just saw like we were like the next McDonald's with billions and billions served, with 540,000 unique views, 4 million page views, almost 2 million API calls. We were on a roll. We told the SAB that we were doing great work and that we had a lot to be proud of. The end of the investment that NIH had made in our initial activity in BioPortal. And then there was a kind of a pause. And then the SAB said, that's really exciting, but now can you do something else? And our Scientific Advisory Board admonished us that this all looked really good, but maybe ontology had run its course. Maybe we should be thinking about what would be next after the world of ontology, and maybe we should not just be putting more energy into BioPortal, but thinking about something else. That was a rather sobering kind of comment. It kind of dampened the whole afternoon, so to speak. And what I wanted to do is just show you where the SAB may have been a little prescient, and in many ways, maybe oversimplifying. I don't think Google Trends is necessarily the best metric for social demography. But if you look at the interest in the word ontology over time, I was surprised to see that it kind of hit a peak, so to speak, in 2004, and it was steadily decreasing. And clearly, by the time we had that SAB meeting in 2015, we were at a nadir. And I don't think we gauge the importance of our work based on Google Trends. But this kind of data was concerning to me, obviously. And I've had a lot of time to think about why are these things, why is interest in at least this word changing? And what I've heard over the years are a few things. I've heard that ontologies are old-fashioned, whatever that means. I hear all the time that ontology languages are too complicated. I hear that ontology engineering is just not an interesting problem. Ontologies coerce people to adopt rigid worldviews, and we need to find ways of allowing people to think more creatively and more flexibly. And of course, what I hear all the time, and certainly what I heard in the review of my recent grant application for continued support of BioPortal, is that generative AI obviates the need for ontologies altogether, and we should just accept that AI is a new thing, and ontologies are just sort of the old way of doing things. It's kind of sad. Let me go through these bullets and sort of get your thoughts. We say ontologies are old-fashioned, but we have a really bad habit in our field. We always go back to Aristotle. And I guess anytime we try to explain how there's a direct linkage between modern computation and the ancient Greeks, we got to be in trouble. So in some sense, maybe it's our own fault for trying to always draw those threads, even though they're incredibly relevant. But maybe it turns people off, and maybe they think ontologies indeed are old stuff. I'm not sure about that. I do hear all the time from people that ontologies are too complicated. And I recall being at meetings like ISWIC in the past, trying to advance the idea of the semantic web and being told by people, mainly from industry, that this is just never going to fly, that these languages are much too complicated. If it takes all of these special symbols just to describe a pizza, we're in trouble. And that we're not going to get much excitement about using ontologies if we make people use logics that they don't understand with terms they don't understand. And we need to simplify the world. In fact, what we have seen, of course, is a considerable transition in recent years from OWL and other standards to graph databases. And maybe that's part of our what we should expect when people are afraid of things they find too complicated. What drives me nuts, though, is this complaint all the time. Ontology engineering is just not an interesting problem. And that's what I don't really know how to respond to. I myself went into this field because I actually think it's really interesting to be able to build models of the world. I think understanding our world in symbolic terms is not old. We've been doing this for 2,000 years, but I think it's what makes life extraordinarily fascinating. And I think from a personal perspective, this is really great stuff. But I don't have a good retort to people who tell me that ontology engineering is not what we should be doing. And I sort of believe that for something we discuss in a bit. I hear all the time as well that ontologies are just bad for people, that ontologies are coercing people to adopt rigid worldviews, and we don't like that idea. I'll explain this really by way of an analogy and a story I can tell you. 4 years ago, the National Academies convened a committee to look at the problem of ontologies in behavioral sciences. I had the pleasure of serving on that committee with a lot of other distinguished people. And we were brought together mainly because a number of sponsors, mainly the NIH, NSF, some societies, including the American Psychiatric Society and the American Psychological Association, were really concerned about the standards that were being used to describe behavioral and mainly behavioral science, but also psychiatric disease. And people in clinical medicine turn to the Diagnostic and Statistical Manual of the APA as a canonical example of a bad compendium that doesn't make it easy to describe disease, that doesn't have any kind of standard way of classifying things, even though it was intended to have that purpose, and now and dearly needs to be replaced. That was one motivator. The other motivator, of course, is that NIH doesn't see any great relationship between what people do in neuroscience and what we learn about in behavioral science, but there's got to be a connection there somewhere, and our ontologies currently don't allow for those kinds of connections. And really the biggest problem that was articulated, I'm quoting psychologists, because this is not something that I've had a chance to observe directly, is that in the field of psychology, there is so much emphasis being given within academia on investigators creating new theories, claiming that they have brand new ways of thinking about behavior without necessarily relating their theories to anybody else's theory, because that's the way you get tenure, that there's an explosion of theory with very little commonality. And the lack of standards in behavioral science really makes it impossible to understand how one person's ideas might relate to those of another. And that the lack of standard vocabulary, as I said, makes it impossible to relate behavior to neuroscience. And we know that diagnosis in clinical psychology is really confused by the lack of any kind of consistent axiomatized standard nosology, and the best that we have is DSM. So we all got together, and the idea was we were trying to advocate that, well, what we really need are better ontologies for behavioral science. And what was really surprising to me, these very erudite and distinguished psychologists on the committee really were very concerned that we might be imposing ontology in this new area. The kinds of arguments that we got were that ontologies are bad because they constrain what people can think. And if we create ontologies where they don't exist in behavioral science, we may force people to adopt worldviews that are rigid, that do not evolve, that cannot accommodate new data, and we actually may ruin scientific advance. Yeah, I
Hey,
see a
Mark.
hand. Hi.
Yeah, Mark, this is Todd Schneider. Um, some of these views that you're relaying to us, I find interesting. I understand some of them, but for those people that are presenting or relaying these or providing these negative understandings, how do they understand ontology? In particular, the one about forcing you to think in rigid terms or about constraining what people think brings to my mind a question in my mind as how do they understand what an ontology does, is, or how it's used? Do you have any insight in that?
No, that's a very good question. And I think from their perspective, the only ontology they know, and many people will be hard pressed to call it an ontology, would be DSM. They are concerned across the board that DSM doesn't clearly provide definitions for the entities that it tries to describe. They're concerned that DSM is confusing because one can have the same kinds of attributes for one disease as for another. And so the ability of DSM to distinguish across diseases is not always easy. And so they view that as a serious problem. But they have this gut feeling that if there were ontologies that were describing experimental conditions, that those experimental conditions would be described in such rigid ways that people could not be creative. And I obviously view this more as I don't know how should I frame this nicely, just as a concern that's not based on a lot of experience. But it was very influential in the committee. And the reason I'm mentioning it is because it just shows you some of the biases that are out there in ways that some of us who deal with ontologies on a daily basis often are not even thinking about.
Thank you.
Yeah, it was very, very surprising to me, but it was a very, very real concern. They felt that ontologies would be straitjackets that would prevent people from becoming creative. And most important, and I guess, and this is where really the motivation is coming from. They describe psychology as an academic discipline where tenure is granted to the people who come up with new theories. And if you are relating your theory to someone else's theory, that is not nearly as worthy of tenure as something totally novel. I don't know if we have any psychologists on the call who want to speak to that, but that is how the discipline was described to members of the committee.
Well, let me ask you the follow-up question then, Mark. These views that you're presenting to us, are they coming from people in only or strictly in academia, or as opposed to the rest of the world?
It's a very biased sample. We're talking about maybe a half
Okay.
dozen academic psychologists and behavioral scientists, but they were almost uniform in their belief that this was a problem. And of course, what they also said, as I have on my slide, is they have this conviction that they're, oh, sorry, Mike.
So yeah, sorry, I couldn't find the virtual hand raising thing. I just wanted to ask you, like, when you're talking to these people who say, oh, nobody wants ontologies, do you ever get into discussions of Neo4j? Because Neo4j is like really popular. Well, at least from the people in industry that I talk to, it's really popular. And I mean, that seems to kind of show that what people are saying is not true. And I'm wondering, why is it that Neo4j is so popular when it seems like a lot of people are resistant to ontologies? And is there some something we can do differently that we should be doing?
Yeah, well, I think part of the problem is that logic is just unpopular. Basically, being strict in the way we describe things is something that people somehow have difficulty with. Many of us were around in the early 2000s and remember the language wars when there were alternative ways of attempting to express ontologies. And in biomedicine, which is my discipline, I had enormous difficulty trying to convince biologists that they wanted something a little bit more formal than just initially just an unlabeled graph as a way of describing ontologies. They understood unlabeled graphs, and that was really easy for them to spot. As soon as you make things directed, as soon as you actually started add more nuance to the representation, they got really scared. And again, I think it's because this is really the ways in which people begin to think about the world, the way they're raised during their academic formulation, so to speak. But you're right. I think what we're seeing now with the advent of graph databases and Neo4j in particular is that people really want to find an easy way of representing things because I think the more formal mechanisms scare them a bit. And I'll say more about that later, but I think it's a really good point.
Thanks.
And yeah, lots of conversations about whether behavioral science is just simply too complicated to comport with any ontology or taxonomy. Basically, my discipline is by intrinsically harder than your discipline, and therefore what may work in your science doesn't work in mine. That was it was an enlightening experience for me. What was interesting after 2 years of a lot of conversation is that the committee agreed ontologies actually had an important place to had a role to play, that we need to not be afraid of semantics, that we had a lot to do that we could do to enhance science and behavioral science and neuroscience by using ontology. And it was all the good things that you would expect. But what was for me most enlightening was that it was 2 years of really tedious conversation. And these are not the kinds of conversations that I usually have with my friends in the ontology community, but obviously folks who were trying to be convinced that ontology might solve some of their problems. And then finally, what I'm sure we're all hearing a lot of, and it was just driving me nuts, is that generative AI is going to solve all our problems and we should stop worrying about all these standards. I think we have a serious problem here. We know that ontologies have played an enormous role in biology, and I don't see any replacement. Let me take a little digression and tell you some of my more recent work, which you may or may not know about, and we'll get back to the generative AI issue. My team has been working a lot in the representation of metadata to describe the data that are associated with biomedical experiments. And this is a trend that started around 2000 with the idea that people wanted to create not only ontologies to describe the kinds of things that need to be said about data, but more specifically formal models that would indicate what needed to be said in terms of the consistent attributes across data sets, like who did the experiment, what was the subject of the experiment, what were the experimental conditions, what were the results. And basically, the very first thing that happened was that people who were working in the area of DNA microarrays realized they had a problem because they started creating a database called GEO, the Gene Expression Omnibus. And people started to store in GEO data about microarray experiments. And when you go to GEO now and you want to find out the age of a subject of some experiment, it's just really delightful. You see that you can see terms like age and pop age and age after birth and age in years and millions of ways of saying age. And if you try to search GEO to find the age of a subject, you have to guess, how is it possible that the user expressed age? You have to guess what typos might have been introduced in that description. Basically, the idea of an ontology initially was just not there at all. And the use of systems like this was totally terrible. You look at the kinds of data that are stored in public repositories rather than the type of metadata, and you see absolutely bizarre stuff. Here is I won't say randomly selected metadata record, but this is a metadata record describing a data set that is described in an NIH database called Biosample. And you can see that it has an attribute called cell subtype, which has the value fresh atypical memory B cells. I'm not sure if that's really a standard term or not. I'm not really sure what makes a cell fresh or not. We see the disease is SLE, which I'm guessing is systemic lupus erythematosus, but that's not a standard term. And then you see other really stupid stuff. You see that the ethnicity of the subject is Asian. Well, Asian is not an ethnicity. You see the karyotype is 46 chromosomes, which is tells you something about the karyotype, but not enough. The population is peripheral blood. That's kind of an odd population, but presumably that's the population from which the cell type was taken. You see the race of the subject is yellow race, and God knows what yellow race is. So you see all kinds of stuff that if you were actually trying to do a search on data, you'd be in trouble because the attributes that describe the data are not very clear, and the values certainly are not ontological terms. In fact, we've looked at biosample very carefully. There are metadata values in biosample that are meant to be Boolean, and yet 73% of Boolean values are terms like non-smoker or former smoker. They're not true or false. 26% of the integers are not numbers. 68% of the terms that are supposed to come from ontologies don't come from ontologies. And so we have a serious problem in biomedicine where we're trying to annotate our data sets in a standardized way so that we can access data, we can combine data, we can do experiments on other people's data, and we can't because the metadata really are so terrible. So what we've been doing in my lab over the past 10 years or so is a system called CEDAR. CEDAR basically gives us 3 steps where we can author metadata templates. We take the reporting guidelines, the list of standard attributes that would describe what you want to say about a data set, and we turn those into templates. We represent those in JSON schema, store them in a library, and then we have a tool which allows us to take templates out of that library and to fill them in with values so that we can take the templates and add values that are consistent with ontologies to have standardized metadata. So we have reporting guidelines that are in the library, values that come from ontologies. We can actually save our work for future reference. So actually, one of the things that we do is we store information in a metadata repository so that we can learn from our previous metadata, see what the patterns are, and use those patterns actually to do predictive data entry and make it easier to fill out new forms. I'll get to that in a moment. And then we upload the data to appropriate repositories. So what does that all look like? Well, we can say that if we're putting data in biosample, that same database where I showed you that ugly metadata record, it has attributes like sample name, organism, tissue, sex, isolate, and so on. And we can say if our sample name is 56 and our organism is Homo sapiens, we get a drop-down list of tissue. And the drop-down list is not just any set of tissues. It's basically a branch of an ontology called Uberon, which is an ontology of vertebrate anatomy. And we get a list of all the tissues that are described in Uberon. And it's not just all the tissues that are in Uberon, it's all the tissues in Uberon that are sorted so that the most commonly used tissues are at the top of the list, with the idea that if you have a sample taken from a human, the most commonly studied tissue is blood. That doesn't seem like a big surprise. And the next most commonly studied tissue is liver, and so on. And so we basically use the ontologies in Bioportal as a source of information to help fill out the blanks in these forms. And we're allowed thereby to create standardized metadata representations that give us information where the attributes comport with standard reporting guidelines and all the values comport with appropriate ontologies. And we're very excited about this kind of work. But basically, people keep on asking, why do you go through all this work? Why do you need these libraries of standards? Why do you have to go through all this human effort to fix up the metadata manually? Why can't we just bring in LLMs? And which is actually how I got started on this train. Let me show you what happens when we just bring in LLMs. Here is a metadata record from Biosample. And this is entered here verbatim. The isolate is TN32, the age is 67. There's a biomaterial provider. The sex is female. The tissue is lung cancer. Show this to ChatGPT, and it'll say, well, look, we should change isolate to sample isolate identifier, because that sounds better. The age should be age of donor. The biomaterial provider should be sample contributor. Wait a minute. All of these changes are not changes to the standard terms. These are changes that GPT wants to make because they sound better or they're more compliant with text that it has learned in previous training sessions, but not because these are the actual standards that need to be used for annotating the data. Sex is changed to sex of donor. Female is capitalized for some strange reason. Tissue is changed to sample to tissue. Lung cancer is identified as not a tissue. Lung cancer is a disease. Lung cancer is not a tissue. But what does GPT do? It says that we should change lung cancer to lung afflicted with cancer, which sounds a bit more literate, but still doesn't tell us what tissue we're dealing with. And so we have a situation which is really almost remarkable, almost humorous, where GPT is trying to use its knowledge of text that it has seen on the web to update these values in ways which don't make any sense. And in fact, what we've done is we've studied what happens if you take metadata from biosample and you just look at the native metadata at baseline, which you see in blue. If you use GPT and give it the data dictionary as a RAG and see if that makes any difference, and you see at best it's about the same. Sometimes it gets worse if you're looking at geo as opposed to biosample. But you get remarkable improvement if you give GPT not only the input data, but you also give it the templates that come from CEDAR. And that should not be any kind of a surprise. Informing the LLM with information about what the standard is supposed to look like gives you remarkably improved performance. But it's really important to stress that the attitude out there in the world is we don't need no standards. We just need to throw LLMs at these problems and they'll all get better. And yet what we can show empirically is the LLMs by themselves really don't do a very good job. And if you really want to do something reasonable, you need to give the LLMs knowledge of the standard if you want to see things get better. So what do we do about all this mess? Well, we can certainly acknowledge that ontology engineering is hard, but that good tools can make it easier. And I think this community has been working very hard over the years on a whole host of approaches and tools, both hardware tools and methods that are applied as workflows that can make ontology engineering more accessible and easier. And I think we have to be simply ready to push that. But we also need to acknowledge to our peers that ontology engineering is something that does require a certain amount of skill, does require training. That's certainly understandable. We have to accept the fact that OWL may not be the one ring to rule them all. As we've already said, there's just so much of a groundswell right now for Neo4j. We can't deny it. We have to accept the idea that there are going to be a number of representations for ontologies in the world. And it's really going to be a function of what people find comfortable, what people find intuitive. And that's going to be something we're going to have to deal with. On the other hand, look, we're going to have to, just another piece of data. I looked at what is the interest in web ontology language using Google Trends, and this kind of shocked me as well. Maybe it didn't shock me that much, but you can see over the past decade or so, there's been a decline in people searching for OWL. And that probably is not only reflective of the fact that people are not as excited about the language as it was the case 20 years ago, but also the advent of graph databases really has changed the world a lot. Meanwhile, we need to educate people that standards are important. We should care about standards, and that if our goal is to allow for people to do secondary analyses of data, to integrate data, to find data, that we can't leave things to the winds. We just have to we have to take standards very seriously. We can't go through the world annotating data with records that don't mean anything, where the terms that we use to describe our work are not standardized and are not guessable by the people who need to do data set search. I mean, that's going to really set science back considerably. And that's why ontologies and reporting guidelines for metadata will always be important. And that's why tools like BioPortal, I think, are going to be important. BioPortal's use of standards is critical. And the argument that we should stop promoting standards and just let everybody use LLMs has no foundation in anything that makes sense to me. But this is something obviously that we'll be hearing in the community, and we have to deal with it. We also have to accept the idea that there are terminological standards that are not necessarily ontological that are increasingly important in the community. And in fact, in our work in CEDAR for metadata description, we're starting to notice that a lot and taking advantage of that. So we're very excited that CEDAR allows us to very easily have dropdowns where people can use ontological terms to describe data sets, and we can use terms that come right out of Uberon and know that when people search for breast or liver or bone marrow or blood, they'll be using Uberon terms and they'll get the information that they need. But in CEDAR, we've also recognized that people want to use other kinds of control terms that are not coming from ontologies. You can see, for example, that CEDAR allows people to use ORCIDs, which are increasingly important and not really elements of any defined ontology, but ORCIDs are standardized ways of talking about author identification. We also have RORs, research organization registry entries, which allow us to talk about the institutions where research is done in a standardized way. Again, not an ontology, but a standardized term from a different kind of naming authority. RIDs, which are research resource identifiers, PubMed terms. And so basically, CEDAR not only allows one to use ontologies as the basis of annotating data sets, but for example, we could have RORs and principal investigators and publications all coming from appropriate registries. So my team whimsically showed me how they could say our institution is Stanford, and we get the ROR for Stanford. They wanted to look up me as a principal investigator, and you would get my ORCID. They can look up publications and get a PubMed ID for a publication that might be relevant for a particular data set that's being annotated. And so I think we have to recognize that ontologies not only are representable in many representations other than OWL, and they're not the only game in town, but we also have to pay particular attention to the kinds of naming authorities like ORCIDs and RORs and RIDs that are sort of taking over the world as well. So what do I keep hearing? I keep on hearing that ontologies are old-fashioned, they're too complicated, that ontology engineering is just not interesting anymore, that they coerce people to adopt rigid worldviews, that they really don't need to be in our vocabulary anymore because generative AI is going to solve all the world's problems. Well, there are obviously ways we can try to get around those terms, those issues. And I think all of us just have to realize that being complacent is not very helpful right now, because the world clearly is trying to look for alternatives to the ways that we are used to representing standard descriptions. And we have to recognize that it's important not only to be able to accept that some of those alternatives are legitimate, but also understand what their limitations are. So despite the fact that our world is changing out from under us, despite these Google trends that I've shown you, basically symbolic representations are always going to play a role in organizing data, information, and knowledge. We're not going to get around that. There's something intellectually important, I think, in the creation of symbolic models that will help us understand the world. And even though my scientific advisory board told me 15 years ago I should get out of the ontology business because they're just not interesting, I think they're obviously incredibly important and incredibly interesting. And precision in management of information really depends on precise ontologies. And despite what happened to my recent proposal, and despite all the stuff I hear about LLMs, I don't believe that LLMs will ever obviate the need for access to terminological standards. And so, although the future, I think, looks good, things are a little cloudier than they may have looked when we all started these ontology summits. But I'm feeling pretty excited about where we're heading, with the caveat that things are a little bit more complicated than they've been in the past. And let me stop there and let's open up the floor to conversation.
Hey, Mark, I'll jump in first. The point you made about the terminological standards actually points to something you sort of suggested implicitly, is that what do people need in terms of the representation? Do they want to have their data nice and clean and have it interoperable, or do they actually want to do something more sophisticated in terms of reasoning? And that's where the symbolic part comes in. So if you can have common terminology for a particular domain, you might be okay. But if you go cross domains, those common terms, in terms of their interpretation, may not be consistent. So again, what needs to be solved? What's the problem? And a lot of, I think, the issues that you were pointing to are sort of almost application dependent, very specific context dependent. And maybe they don't need all the work that's necessary to create an ontology for them. Or maybe not. Depends. What are the needs, the requirements?
Okay, that's a lot. That's a lot of stuff to unpack there. Um, I think you're right that there's so much context that determines how we view the kinds of stuff that we're describing with ontologies. That it is not a simple matter for many uh, practitioners to know for sure that the terms that they're selecting from one ontology may be useful for some other person in a different discipline trying to do a query or trying to do some sort of data integration. I think the more fundamental problem is that, at least in my world, which is where biologists are using ontologies to describe their data sets, they're doing this work not for themselves, but for someone else. They're trying to anticipate, why would someone else care about a description of a data set that they may want to find and use down the road. And it's very hard to anticipate what the nature of those queries will be and how the problem will be construed so that the appropriate terms are selected in the first place. I don't have a good answer for that, because the biggest challenge, I think, in people using ontologies is trying to anticipate the usages of people who are in different environments and different contexts. And that's why it's so important when we create methods for annotating data or using ontologies in that context, that we try to constrain the context as much as possible and make it as clear as possible what the data are going to be used for. That's, I think, one of the reasons the psychologists were so scared about people using ontologies to analyze and to annotate psychological data, because I don't think they feel comfortable being expressive and explicit about all the assumptions that their data sets are making. So that's a long-winded way of saying I don't know, have a good answer for that, and it's a real serious problem.
Yeah. So this is Stan. This has been a
Hi,
great,
Stan.
hey, wonderful conversation. And I don't feel so lonely because what I get, being involved directly with SNOMED and LOINC, SNOMED is actually an ontology. LOINC isn't, but we're actually moving LOINC into an ontologic representation consistent with SNOMED's, simple ontology kind of things. But yeah, I mean, the questions here are the same. Why are we bothering to make LOINC codes? Why are we bothering to make SNOMED codes? Why do we, people can just talk, and LLMs are going to understand that and be able to reason with it. And, I come back to some very fundamental things. One is, everything that we know, and then everything that we would want to put into an ontology originates from observation of the real world, being able to describe accurately what we observe in the real world. And natural language without, some thoughtful constructs doesn't do that. you know, and so it comes down to basically, and a lot of other things that you said really resonate, which is the metadata associated with it, being able to establish the context in which the data is being collected, who collected it, what was the purpose for the collection. All of those kind of things are things that enable the downstream use of the data and subsequent derived ontologies that make it useful. So you've given me some ammunition now as I discuss why Loink and SNOMED are still relevant. But
No, I appreciate that, Stan. And I think it's really hard for people to understand that LLMs know only what they've been trained on. And I'm sure we can all find several thousand terms in SNOMED that LLMs have never seen and would not know what to do with. I think it's true for all of science. John, you had your hand up a while ago.
Okay, one thing that I'd like to mention is the solution that many systems have developed, in particular, the simple way of having a dialogue so that when somebody answers a question, whether it comes in typing or in verbally, that what the system does is translate it into its best approximation. And first order logic or extensions to that are superb. OWL is a disaster. That does not map easily to natural language, but first order logic does. And so what you do is translate it to FOL with whatever, and then interpret it in whatever ontology you're using, and then come back to the user and say, translate that back into English and say, is this what you mean? And if they say yes, then you go with it. If they say no or give some correction, you then translate the new thing back into your internal representation, translate that back to English and say, is this what you mean? And this way, after a while, the speakers or the typers who are typing things in get used to the kind of terminology that the system comes back and accepts, and they eventually adopt whatever ontology you happen to have used, and so their questions are accepted more frequently, but occasionally they do have to have a question that comes back, is this what you mean?
Yeah, fair enough. The biggest challenge we have in the workflow that we're talking about in science is that these ontologies are usually used and the term selected by people who have nothing to do with those who are actually using the completed records. So if I annotate my data set with some ontological terms, and then some scientist down the road finds it, he can't ask any system, what did I really mean? It has to stand on its own, and that's a real serious problem. I don't know. I'll never know what yellow race is.
Mark Fox, why don't you speak up?
Thank you very much, Mark, for the presentation. I really enjoyed it. I just wanted to provide a use case within the domain that I work in, which is cities, smart cities, whatever you want to call it, where the importance of ontologies stand out, and where there is a recognition of the importance of ontologies. So within the city domain, there are many different types of systems. And there are non-operational systems, maybe planners use this, that don't have a direct effect on the operation of the city. But there are operational systems that deal with day-to-day decisions that are implemented immediately, whether it has to do with the problem of street lights, traffic lights, dispatching emergency services, et cetera, where the data has to be right.
Yeah.
Okay, and so within the database world, it's referred to as a system of record. And that's where all the valid data is supposed to exist. And we can't use an LLM as currently conceived as a system of record because there's no guarantee that you'll get the same answer every time you pose a question. Anyway, so it can't be used as a system of record. We have to have a system of record that an LLM can call out to, whether using RAG or whatever technology. And that ontology has to not only provide the representation, the data model for the system of record, but it also has to be the data model that all the different silos within the city have to begin to converge on if they are to share information. So we just see this ever increasing growth in the use of ontologies within the context of cities for these reasons and others. But going back to what you were saying about logic and what John was saying about logic, et cetera, if you look at any of the ontologies that we create these days, I tend to call them ontology light. They don't provide complete axioms for almost anything. At most, we provide value restrictions on the range of properties. And the reason is very simple. If we started adding into these ontologies, even though we think it's important for understanding the semantics, if we started adding in, it's not clear who would understand what the hell we're talking about. And so it's a slow progression to get them to the point that you're doing something beyond what a concept model is, but you're not moving directly to full first order logic or whatever logic you want to refer to. And that's turned out to be important for us in terms of people understanding what it is that we're doing in terms of adoption by a city within their information systems, data models, et cetera. And this is also true with the work we do on international standards. And so we have published in the last few years 3 international standards on city data that is based on ontology light, where we're limited in terms of the use of logic, but it's hopefully understandable to the cities who would employ this. And there are more of those standards that we're working on over the next few years. So important area for ontologies, and it is being recognized. And just one point before John comes back on. The Department of War in the United States, NATO, the Department of Defense in Canada, have now coalesced around building data models based upon BFO, and in particular the core common ontology, common core ontology. So there's an increasing adoption of this in some areas. Thank you.
Yeah, that's helpful, Mark. And I wish I could say that in the discipline that I work in, people had the same kind of commitment to precision and understand the bad things that could happen when people have mismatches between physical entities as well as intellectual entities. But I guess it's a very different kind of world, unfortunately, in biology. Also, I guess the accountability is not as strong. I guess if your building falls down or your road doesn't actually meet up with its where it's supposed to be going, there's no one really to blame, I suppose. But I hear you, John.
Okay, the example that I mentioned where you can speak to the system in your ordinary English or other language and have the system come back with a question and say, is this what you mean? Has been implemented by Wolfram. Wolfram has the most complete and extensive version of mathematics. Almost every mathematical system you can imagine, he has implemented in a very precise way. And the Wolfram language is a very sophisticated language that takes a lot of time, and mathematicians can only use it. However, what Wolfram did is to add an English front end along the lines that I was just saying, so that you can ask the question in your ordinary English language. Wolfram translates it to whatever mathematical system it is required, and then comes back, translating that back into an English sentence and says, is this what you mean? And that has turned out to be superb, that mathematicians who don't know the Wolfram system, but they do know mathematics very well, can ask questions in their own version of mathematics. The system translates it to Wolfram. Wolfram's version comes back and says, is this what you mean? And very quickly, the mathematicians get to use the system without ever having to learn this very complicated internal language.
Good example.
Mark, one last point I want to ask you about. In all of those interactions you've had with the naysayers, is the general notion of communication ever brought up? In that, my perspective on ontologies is that it facilitates communications between people between people and machines, between machines and machines?
All the time. And yet,
Oh,
I guess there's so much faith in ordinary natural language communication under usual circumstances that people don't see this as a problem. I mean, we spent 4 years at the National Academies working on these ontologies for behavioral sciences. There was just an announcement about a month ago that there's going to be a new version of the Diagnostic and Statistical Manual being released by the APA to replace DSM-5. And after all of this discussion of why ontologies may be valuable, why precision and descriptions may allow capabilities that are not possible using the existing version of DSM, the new version of DSM, as I understand it, is going to look just like the old version of DSM, except will have additional attributes that may be valuable for describing certain psychiatric illnesses. So we really are not learning very fast. And it's very, very frustrating. Janet?
Yes, hi, thanks. The in your presentation here, I think there's two things going on. One is the question of whether there should be care in the choice of terminology and metadata. And that does not seem like it is that hard of an argument to make. On the other hand, the word ontologies is a scary Greek word. Nobody knows what it means or why it goes back to Aristotle or, so arguing that ontologies are the way to accomplish care and standards in metadata and terminology is where there's an issue. And I think that the choice can be either, saying ontologies, ontology light, and sort of expanding beyond ontology and having ontology be something that necessarily has a logical structure. Or one can just say, well, ontologies is, covers the whole field of taking metadata seriously and terminology seriously. And so we can, I think that's probably the better approach to keep ontology, to revive ontologies by saying, well, look, we were here early on taking terminology very seriously. And now we have these other issues about communication, as Todd said. And it all falls under the umbrella of ontologies. And whether you want to have just interoperable schemas, or you want to have some kind of glossary, or whatever you want to have, let's take seriously the question of terminology. I think that on that path there should be a very robust future.
Can't disagree with that, and I think that's really a great way to end. I know we're at time. I really want to thank you all for dialing into this. This has been really a wonderful conversation. I want to just reiterate that I think ontologies are interesting, even though my SAP did not. And I'm glad that the summit persists and that there's so many people who are actually of like minds here. That's great.
So, yeah. Unless there are any other comments, I mean, I've personally did some research on behavior change. This was, behavioral. When we were doing that, we immediately discovered that no two psychologists have the same theories. This diversity was really pretty impressive. So we ended up actually building our tool by having a lot of smaller micro theories. There's just pieces that the psychologists could put together to make their theory. So, it actually worked, and we got a system that would actually help people change their behavior in healthy ways.
That's great.
So it is possible, but I mean, we had to recognize and you had to understand the field that we were working with before we started building ontologies for it. rather than, saying, okay, this is what the field ought to be, and then imposing it on people. You have to recognize how they actually work.
One comment. Ontology is the theory of metadata. So when you're talking about metadata, you're talking about ontology. They're identical.
Yeah, I think that's the solution.
So with that, I think we should adjourn. Thanks again, Mark, for this really very, very nice talk. I think it's a call for action to all of us that we should take very seriously. And with that, I will adjourn. Thanks again to everyone.
Thanks, everybody.
Bye. Oh, and next week, we're going to have Nicola Guarino, who is going to be speaking. And ask everyone, please come to the next talk. That will probably be equally interesting.